refraction and reflection using Huygens principle. Yes. So let us understand the refraction phenomena with the help of Huygens principle. It is very small, and this is one of the important type. See, in the first case, what is happening? From rarer to denser medium, it is moving. After that, we'll see from denser to rarer, it will go. It will be just inverse. And after that, we will see reflection of plane wavefront with the help of Huygens principle. Refraction, then refraction, then reflection. Reflection by plane wave from rarer to denser, then from denser to rarer. Then we will see reflection phenomena in the same medium. Okay, so let's see the reflection of plane waves. Reflection of plane waves. Yes, you have a diagram. You have to copy, paste this diagram. So what you will do, yes, you will have this diagram. In this diagram, you have an interface. What is the meaning of interface? What is the meaning of interface? Interface is a boundary or a line which separates two medium. Which separates two medium. Where are those two mediums? First medium is your rarer medium, while another medium is your denser medium. This is your rarer medium, and this one is your denser medium. And in the last session only I explained what is the difference between rarer and denser medium. Where speed of light will be more, that will be rarer medium. If speed of light is less, then it will be denser medium. Okay, then from there a plane wavefront is coming. Plane wavefront will come like this. Actually, plane wavefront is like this, but we are not able to see complete this. We are only going to see this part, 1D view. Okay, here we are going to consider only 1D view. So it will be coming like this. I'll make it with the help of blue marker. This is your incident wavefront, this blue one. Okay, it is coming, and with support of this, I am making this. I'm not changing the name. This A, B are the plane incident wavefront. Angle will be angle I. See this angle. I am not changing the name of the angle also. I am not changing the name. It will be I. Okay, this is I. It is coming like this. See, after striking it A position, see, after striking at this position, what will happen? After striking at A position, A will start emitting wavelets in forward direction, while B is yet to reach here. So B will take some time. It will take some time. See, B, for reaching B from here to here, it will take some time. Till then, A will start its work. Now, A will not stop for B. So A will reach E here. You will take a compass and you will mark an arc here. From A, it had been reached to E. Then our B will reach C. First, what will happen? First, A will reach E. Then what will happen? Yes, our B will reach C. Okay, see, the time taken by B to reach C is equal to the time taken from A to reach E. Why AE is smaller than BC? Because BC is a rarer medium and AE is a denser medium. Okay, then from C to point E, we will join a line. This is angle of incident. This is angle of reflection. This is medium 1, this is medium 2. Okay, yes, diagram is clear. Then we will proceed further. Yes, now what will happen? See, in the beginning, that is at time t is equal to 0. In the beginning, when time t equal to 0, when time t is equal to 0, A head just reaches the surface. A just reached the surface. Reached the surface. A had just reached the surface, while B reaches C in time t. While B reaches C in time t is equal to capital T. Okay. Then later, what will happen? Later, A will produce its secondary wavelets. A will produce the secondary wavelet. Yes, here I will write, let speed of light let speed of light in medium 1 be V1, and let speed of light in medium 2 be V2, and let speed of light in medium 2 be V2. Medium 2 be V2. So if you check what is the distance traveled by light in medium 1 and what is the distance traveled by light in medium 2. So the distance traveled by light in medium 1 is distance traveled by light in medium 1. In medium 1, it will be what? It will be BC. And we know the formula, velocity is equal to distance upon time. That means distance is equal to velocity into time. So I will write V1 into T. I'll write V1 into T. First, V1 into time. And again, in that again, also in medium 2, what will be in medium 2? In medium 2, the distance will be AE. AE means what? V2 into T. What is V2? It will be V2 into T. Time is what? Time is T. Okay. So you can write BC is equal to V1 into T and AE will be equal to V2 into T. Then I'm just erasing this part. Yes. If you add the sine angle, so what you will get? See, you will get sine of I will be equal to, what is sine theta? Opposite upon hypotenuse. What is opposite here? BC. And what is hypotenuse? Check. What is hypotenuse? Hypotenuse is AB. What is BC? BC is V1 into T. And what is AB? AB is nothing. It will be AB. If you check about sine R, it will be equal to opposite upon adjacent. What is opposite? Please check. It is AE. What is hypotenuse? Hypotenuse is nothing but it is hypotenuse. Sorry, here also hypotenuse was AC, and here also hypotenuse will be AC. What is AE? AE is V2 into T upon what we have, upon may we have AC. So therefore this will be sine of I upon sine of R is equal to AC. AC will get cancelled and you will get V1 upon V2 only. This TT AC AC will get cancelled. Okay. Now what? See, we know that V1 is greater than V2, right? Velocity in the rarer medium will be greater than velocity in a denser medium. If V1 is greater, that means sine I is greater than sine R. As angle is very small, you can say that I is greater than R. This is what you have to prove. This is what you have to prove, that angle of incident, this angle of incident is greater than angle of reflection, the refraction. Okay, so this was your derivation for the reflection of plane wavefront. Now in the case of rarer medium, what will happen? It will be inverted. I'll just explain you what are the things. I'll not derive the entire derivation because I'll explain this derivation in detail. So in the from the rarer medium, see, if the cases are inverts like this, so what will happen? If you solve with the help of that concept only, so you will get sine I upon sine R is equal to V1 upon V2, and you will say that V1 is smaller than V2. If V1 is smaller, that means sine I is smaller than sine R. If sine I is smaller, that means I will be smaller than R. Okay, so this is just the inverted case. In that case, it was going from rarer to medium. Okay, now what we are doing, yes, here we will send from denser to rarer. See, this will be your denser medium and this one will be your rarer medium. And same, this will be your interface. What is the meaning of interface? The point at which two mediums are separated. Yes. One of the most important derivation. Yes, by yes, reflection of plane wave by plane surfaces. Okay, by plane surfaces. See, this in this case we are going to study about the reflection part. In this case, you are going to study about the reflection part. So this derivation, I'll explain you with the help of the concept uh, of the similarity. Even you can solve it by 30, 60, 90 degree, but that will be too complicated. So do one thing. We'll solve this with the help of similarity. That's SAS test. Okay, so this will be very easy for you people. So let's start with the derivation. Yes. First of all, what you have a mirror. This is the mirror. This is the mirror. This is the mirror. Okay. Yes. This is the mirror. Then on that mirror, what we are going to do, see, I'll make it here. First, you will take a mirror. What is this? This is your mirror. On that mirror, you will make a big W. You will make a big W. Sorry. You will make a big W. Okay, you will make a big W. Then what? Then this W had been made. Then you will take a wave. This will be your wave. First mirror, then W, then you will take a wave. Make sure wave should not be parallel to this. Make sure wave should not be parallel to this. Sorry, it went by mistake. Yes, so first what you have a mirror. I'm extremely sorry. Yes, you have a mirror. Okay, on that mirror we have a W, a big W. Okay, then here we have a plane wavefront. This plane wavefront will go at this after some time. Okay, I will name everything. Yes, I'll name the first one as this wavefront. I will name it as AB, and this I will name it as A dash B dash. Also make one line, normal line like this. Okay, normal line. Okay, this will be a normal line. Normal line. Okay, so this will go here. Then what will happen? See, from A, it will be now A dash. It will be A dash, and this one will be B dash. Okay, this will be A dash, and that will be B dash. After reaching here, A will see. After reaching there, what will happen? This B will move further. A is here. A will start emitting its wavelets in backward direction, right? Because that is a mirror now. So it will produce in a backward direction here somewhere. I'll mark here as E, and B will reach C. The time taken by B to reach C will be the same time that is taken by E. So here what you will do, you will join E and C. Okay, you will join E and C. Okay, once more. Yes, see, I'll explain the help of this diagram. Yes, first what you did, you made a W. Okay, you will make a W somewhere like somewhat like this W. Here the W is quite different. Just understand here only. Okay, then what will happen? Yes, this is your angle of incident, and this will be your angle of reflection. Okay, that will be angle of incident. That will and angle of reflection. Now see what happened in triangle. See here what we have. Just to see, we have two right angle triangle. This one will be also right angle triangle. Why? Because we have 90-degree here, and here also we have a right angle triangle. Why? Because here also we have 90-degree right angle triangle. Okay, both place we have a right angle triangle. So we have two right angle triangles. So if you check here in triangle AEC, A, E, and C, in triangle AEC and triangle ABC, in triangle AEC and ABC, see what you will get. You will get angle E and angle B are same. Why? Both are 90-degree. Okay, so I will write 90-degree each. In both of the case, you will see that AC are common. AC are common. First, I will write that AC and AC are common. Then I will write common side. Then angle. Then again, if you check now, this BC will be equal to AE. Why? Time taken by B to reach C is the same time taken by A to reach E. So I will write here that AE will be equal to BC. time taken to travel same day to taken time to travel distance is same. Time taken to travel distance is same. Okay. So from this can we conclude that triangle AEC is similar to triangle ABC. That means what? That means this angle BAC will be equal to triangle ECA. BAC will be equal to triangle BCA, which is this property. This is the property of SAS test, side angle side test. That means you can say that angle of R will be equal to angle I. Angle R is equal to angle I. Okay, so this is the derivation in which we have to prove that angle of incident, angle of reflection, angle of incident, angle of reflection is same in the case of reflection of plane wave. Okay, yes. Let's do some questions based on this. The first question: what does Huygens principle describe? What does Huygens principle describe? Behavior of magnet, the propagation of light wave, motion of planets, or properties of sound wave? Which will be the right answer? Anyone? Yes, the right answer is propagation of light wave. Okay, then in Huygens construction, what does envelope of secondary wavelets produce? Envelope of secondary wavelets. In Huygens construction, what does the envelope of secondary wavelets produce? Yes, not backward, not sound wave, not magnetic field. It will be forward moving wavefront. Okay, then next. Huygens wave theory of light cannot explain what? It can explain interference, it can explain diffraction, it can explain polarization, but it cannot explain photoelectric effect. For that, you will have to consider light as particle, just that we will study in dual nature of radiation and matter.